Alright, so let me get this. Okay. Okay, so number one, it's 1 through 4 is actually talking about writing a function given transformations. So you're writing a function, and first off, it's a cosine function. So I've got cosine of an amplitude of 2, which means that goes out front. Got a 2. We've got a period of 8 pi, so I'm going to have to use that to figure out what b is. So I've got 2 pi divided by b equals 8 pi. And then if I want to solve for b, I'm going to multiply by b and divide by 8 pi. So 2 pi divided by 8 pi equals b, and that simplifies down to 1/4. So I'm going to put a 1/4 right here. I'm going to put another set of parentheses and put x, and then shift to the left. Pi over 2 means plus pi over 2, and then up 6 means plus 6. So my final answer will be f of x equals 2 cosine of, distribute the 1/4 x, or x divided by 4, and then plus pi over 8 plus 6. And that is my function. All right, number 2, I've got a cotangent function. So f of x equals cotangent of something, and then something else, and then an x, and then we'll go from there. Okay. Vertical stretch by a factor of 6, which means there's a 6 out front. A period of 3 pi over 2. So the formula for the period for cotangent and tangent is pi over b, not 2 pi over b. So pi over b equals 3 pi over 2. So if I'm trying to solve for b, I multiply by b, right? And then if I'm trying to get rid of 3 pi over 2, I multiply by 2 over 3 pi. So 2 over 3 pi. And the pi simplify out, I'm left with 2/3. B equals 2/3. So we'll put a 2/3 right there. Shifted to the right 5 pi. That means minus 5 pi in the interior. And then reflected over the x-axis means a negative out front. A reflection over the x-axis. So my final answer will be f of x equals negative 6 cotangent of 2/3 x minus 10 pi over 3. And there we go. Okay, number 3. I've got a secant function, which is just the reciprocal of cosine. So y equals secant of something. I changed y because it doesn't really matter. And I'll go ahead and change it to theta. So theta, and then those parentheses, and we'll go from there. Okay. So first, a vertical stretch by a factor of 10.5 means I'm going to put a 10.5 out front. And it's terrible. Okay, a period of 18. So that doesn't involve pi at all, and that's okay. You don't have to. Since secant is the reciprocal of cosine, the formula for period is still 2 pi divided by b. So 2 pi divided by b equals 18. And so then if I want to solve for b, then I multiply by b and divide by 18. So 2 pi divided by 18 equals b, which means pi over 9 is b. So pi over 9. And then we've got to the left 3, which means plus 3 in the interior, and up 7 means plus 7 on the outside. So final answer is y equals 10.5 secant of pi over 9 theta plus pi over 3 plus 7. Okay. We've got sine with an amplitude. Let's do f of theta. Sine with an amplitude of 4. Give myself a second. Okay. With an amplitude of 4 means 4 out front. A period of 5 pi over 8 means it's sine, so 2 pi. So 2 pi divided by b equals 5 pi divided by 8. Multiply by b, and then multiply both sides by 8 over 5 pi. So multiply by b, and then multiply by 8 over 5 pi. 8 over 5 pi. So the pi's will simplify out, and then you'll be left with 16/5. So I'm going to put a 16/5 right there. Then it says go to the, should left 5/16. So I'm going to go plus 5 pi over 16. Down 7/2, so that means minus 7/2. And reflect it over the y-axis. So that actually means a negative 19. So my final answer will be f of theta equals 4 sine of negative 16/5 theta minus, because I'm distributing that, the 16 and the 5's cancel each other out, and I'm just left with minus pi and then minus 7/2. Okay. All right, so here we go. Now the other option, one thing I didn't address is that you could have figured out c just by saying negative c over b. So like on this one, I could have written f of x equals and then put negative 6 cotangent of, and then just filled it out from there. If you have a period of 3 pi over 2, you figure out what b is. B is 2/3. And then you say, okay, the phase shift is negative c over b. And b is 2/3 because of that. And you set it equal to the actual phase shift, which is right 5 pi, so positive 5 pi. And then you solve for c. So if I were to multiply both sides by 2/3, and then get rid of the negative, then I would end up with negative 10 pi over 3, which is what you get right there. Okay, so that's just another way of thinking it out. Alright, let's start graphing. Graph the following trig functions with indicated domains and state transformations. Okay, so first off, the negative out front is a reflection over the x-axis. Make sure we do that. The 2, I call them amplitude with sine and cosine, but I'm just going to call it a vertical stretch. I mean, it's the amplitude of the cosine wave, but it's really just the min and the max from your midline. So I'm just going to go with vertical stretch by a factor of 2. The plus 2 means go up 2. The 8 has to do with period. So the formula for period on secant, same as cosine, 2 pi divided by b equals 8. Just kidding. I'm trying to find the period, and I've got b. 2 pi divided by 8 equals, yeah. Okay, I'm being ridiculous. Period is 2 pi divided by b. All right. So 2 pi divided by b is pi over 4, which means the period is pi over 4. Okay, so I'm going to come back to that in a second. And then the phase shift is negative c, so negative 3 pi over 2, divided by b, which is 8 over 1, which means multiply by 1 over 8. So we're going to the left 3 pi over 16. Okay? All right. So the formula, or for the, sorry, the formula, the period of the wave is 3 pi over 16. And I need to, pi over 4. And I need to graph from negative 3 pi 16ths to 5 pi 16ths. So I'm going to go ahead and sketch it out over here and just make sure, or see if it works, okay? So if I let this be 0, 1, 2, 3, 4. The goal is always for me to be able to, like, on secant, cosecant, sine, and cosine, let 4 tick marks be the period. So I'm going to let 4 tick marks be the period, and I've got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. I've got 6. So we'll see if we can fit in there. So if this is 1/4, then half of that is 1/8, and half of that is 1/16. So if that's 1/16, then this is 2/16, and this is 3/16. Okay? I need 5/16, so this is 4/16, and this is 5/16. So we'll be able to fit it on the right-hand side, and then the left-hand side is just negative 3/16, which is just 3 tick marks, so we're good. So if I'm going to let this be pi over 4, the period, then I'll let that be pi over 8, and I'll let that be let's see. Sorry, my computer's on blank. Okay. Pi over 16, and then this is 3 pi over 16, and this is 5 pi over 16. And I'm supposed to graph until 5 pi over 16, and then until negative 3 pi over 16. Okay. I would like at least the endpoints indicated, and on one side all of them filled out. Okay. All right. We said go up 2, so that is my midline. Okay. So I'm going to make my tick marks on there. Okay. Amplitude is 2, so I'm going to go up 2 and down 2 from, I said amplitude, didn't I? Vertical stretch is 2. Although if you wanted to, you could just draw your dotted lines from here to here to help remind you. Okay. Now what I'm going to do is I'm going to figure out the original cosine wave, and then I'm going to phase shift it. Okay. So the original cosine wave, so it's just general cosine, right? It is a negative cosine. I should have drawn that. Forget it. Okay. And normal cosine wave, this would be pi over 4. This would be pi over 8. Pi over 16, 3 pi over 16, right? We are shifting it to the left 3 pi over 16, which is, in this case, 3 tick marks, right? So what I know is that, we'll just go from the right. This point right here will be over 1, 2, 3. It'll be at pi over 16. So this point right here, this minimum of my cosine wave, my negative cosine wave, will be at pi over 16. So I'm going to go ahead and put that right there. Okay, this one right here, the one at 3 pi over 16, would be at 0. And that right there is enough for me to continue the wave, because I know that everything else is just a continuation of this, right? So when I'm not drawing my answer, I'm drawing my cosine wave. That'll help me draw my answer for secant. So I know this does this, and then it does that. And then there we go. Okay, so that is my cosine wave. Shifted to the left 3 pi over 16, yeah, which is 3 tick marks. Okay, so if you drew a normal cosine wave, it would be here and here, and then I move that 3 tick marks over. Okay, so you can kind of see that. All right, but my final answer is the actual secant wave. So here's what I know. Wherever cosine hits the x-axis, secant has a vertical aspect. So vertical aspect here and here and here and here and here. If cosine has a maximum, then that means secant has a minimum. So I'm just going to draw some kind of, it's not a parabolic shape because it has vertical asymptotes, but it is some kind of shape. And there we go. And then I'm done over here, but then over here I have this little piece, so I'm just going to draw half of a maximum. And then there is my, well, kind of, no, I should have gone closer, but oh well. That is my negative secant wave. Okay. Number 6. So we've got a negative cosine. Oh, a negative cosine again. Okay. Start with transformations is reflected over the x-axis. We've got a period 2 pi divided by b, which is 1/3, which means 2 pi times 3, which is 6 pi. So I've got a period of 6 pi. My phase shift is negative c over b, so a negative pi over 4 means positive pi over 4 over 1/3. Divided by 1/3, same thing as multiplying by 3 over 1. So we're going to go 3 pi over 4 to the right. Let me do that. That's what I did. Let's see. Okay, we'll see. And then the minus 3 means go down 3. Oh, an amplitude. Sorry. The amplitude is, there's an understood 1 out front, a negative 1. I forgot what I was going to say. Oh, vertical stretch. Or actually, there's no vertical stretch or compression. It's just a normal, right? Okay, I'm going to go down 3. 1, 2, 3. Okay. My amplitude is 1, so I'm going to go up 1 and down 1. And my wave will have to fit in between these right here, right? Okay. The period is 6 pi. So what I want to do is I want to play around with 6 pi. Okay. So if I let, they only gave me 3 tick marks, but that's okay. I'm just going to go ahead and play around and see what I get. If I let this be 0, 1, 2, 3, 4, and I let this be 6 pi, then this is 3 pi, and half of that is 3 pi over 2. So if that's 3 halves, and this is 6 halves, and this is 9 halves, 9 pi over 2. And I'm supposed to go negative 9 pi over 2, so that tells me if I let this be, well, actually, this would have to be 9 pi over 2, right? Then I would only go 2 tick marks to the right to get to 3 pi. And I would only have to go 3 tick marks to the left to get to negative 9 pi, negative 9 halves pi. So negative 9 pi over 2. Okay. That would be negative 3 pi, and that would be negative 3 halves pi. Okay. I'm going to draw my normal cosine wave with all of this information, and then I'll do the phase shift. Okay? Although you could do the phase shift immediately and just draw your final answer, I'm going to go ahead and do this. So I've got a negative cosine wave that normally starts at the minimum here, crosses here, has a maximum there, crosses here, and has a minimum there at 6 pi, right? Well, that means at 0 I should be at the minimum, at 3 pi over 2 I should be at the midline, at 3 pi I should be at the maximum, and at 9 pi over 2 I should be back at the midline, right? So then that means here, oh, just kidding, I'm not going to graph that far. I'm only graphing the 3 pi. And I'm only graphing here, so I might as well get rid of that. Okay, and then up here, and then back to midline. So that is my cosine wave if I had not done the phase shift or didn't have the phase shift. Okay, now the phase shift is to the right 3 pi over 4. So here's what I know. If this is half of 3 pi, then this right here is a quarter of 3 pi, right? So that means that right there is 3 pi over 4. I'm going to shift every point over a quarter of or a half of a tick mark, okay? So this one will go right here. This one will go right here. And right here. Right here. Here. Okay. So I'm going to go ahead and connect my actual points. And then I've got these endpoints that are not exactly perfect, right? So we're just going to kind of pretend like I'm supposed to be coming here, right, to a minimum. So then it just does something like that. And then there's just a maximum right there, so I'm just going to go towards it. And there you go. That is my negative cosine wave. Okay. Number 7. We've got a tangent. So I've got, okay, a vertical stretch by a factor of 2. I've got a period. Okay, let's talk about period. Period on tangent is just pi normally, so it's pi divided by b. In this case, b is 1/4. So dividing by 1/4, the same thing as multiplying by 4. The period on this tangent is 4 pi. Okay, and we'll talk more about that in a second. Phase shift is negative c over b, so positive pi over 2 over 1/4. Same thing as multiplying by 4, which gives me 2 pi. So we're going to go to the right 2 pi. Okay, and then the plus 1 means go up 1. Okay, so my new midline is up 1. And period. Okay, so normally tangent has a period of pi, and I don't know if I hope you remember, but tangent in general, what we do is we take the period, we cut it in half, we put half of the period on this side and half of the period on that side, and in general it does this. Okay, so let's make sure that that's going to work. My period is 4 pi, right? So if I want to follow what I just said, then I would let this be 2 pi, and I would let this be negative 2 pi. Okay, let's see if that works for this. I'm going to go 2 pi, and then that would be 4 pi, and then 6 pi. And then 2, 4, 6, 8, 10, 12. Okay, so I'm going to be spanning this entire graph. So this is negative 12 pi, and this is 6 pi. And 4 pi. Negative 6 pi, negative 10 pi, negative 8 pi, negative 4 pi. Okay. So, before I sketch this, because I don't want to sketch the original and then sketch the new with the phase shift because of all the vertical asymptotes, we're just going to play around with the graph and then draw it. So, like I said, normally tangent. And the period is 4 pi, so I put 2 pi here, negative 2 pi there. And then do this. And that's one tick mark. So 4 pi, 6 pi would be my next, right? Okay. But the phase shift is go to the right 2 pi. So 2 pi is one tick mark, so this vertical asymptote is actually going to end up at 0. Okay. So that vertical asymptote is going to end up at 0. This vertical asymptote at 2 pi is going to end up at 4 pi. So once I've got that, I know that every other tick mark is a vertical asymptote. Okay. I also know that every point in between my vertical asymptotes should land on the midline. Okay. And I also know that tangent, normally it goes over, you know, I only give it 2 tick marks because they are elongated waves. They shouldn't be as wide as sine or cosine. Halfway between the midpoint or the 0 and the vertical asymptote, you should have that 1 point, right? Well, since it's vertical stretch by 2, you're going to go over a half tick mark and go up 2 and down 2 to the left. So up 2 and down 2. Okay. So we should see 4.5 waves. Okay, and there you go. All right. The goal, obviously, guys, is that when I make these graphs, I make them to where it fits with a normal window type, with a tick mark that makes sense. Like, I'm not going to make you make the tick mark be, the whole wave or something like that. Okay, cosecant, which is reciprocal of sine. So here we go. I've got a reflection over the x-axis. I've got a vertical stretch by a factor of 3/2. We've got period is 2 pi divided by b, which is pi over 10, divided by pi over 10, so it's multiplied by 10 over pi. Pi's cancel out, and I'm left with a period of 20. Okay, interesting. Phase shift is negative c over b, so that is negative 5 pi over 2 divided by pi over 10, which multiplied by 10 over pi. Pi's cancel out, this simplifies down to 5, so negative 25, which means go left 25. Okay. And then there's no up or down. Okay. So that means my midline is still the x-axis. And I want you to graph from, that should be equal to, from 5 to 35. Okay. No, I'll do that on this too. Okay. So, okay, period is 20. So if I let 4 tick marks be 20, then that would be 5, 10, 15, 20, 25, 30, 35. So that fits. So we'll go ahead and label 5, 10, 15, 20, 25, 30, 35. Okay. So I'm going to, well, just kidding. I'm going to go ahead and do this. Vertical stretch by a factor of 3/2 means up 1.5. And down 1.5. Okay. Okay, let's draw a negative sine wave. So in order to draw a negative cosecant, I just need to draw a negative sine and then do the opposite. So negative sine wave starts here and does that and then does that, right? So I'm going to go ahead and draw another wave because I noticed that my phase shift is longer than one wave, right? So if my period is 20, then that's 20, that's 10, that's 5, that's 15, that's 30, 25, um, 35, and 40, right? All right. This says go to the left 25. Yeah. So if I go over to 25, basically make it a little bit easier on myself, I take this one and I move it right here. Right. So if I go left 25, then that puts me right there. This, if I go left 25, puts me right here. So what I can tell is that I'm actually, instead of going left 25, 25 is just a period and a quarter. So basically just take your wave and go a quarter to the left, 5 to the left, as opposed to 25. So I'm really just saying, hey, this will go here, this will go here, and then this will go here, right? So a little bit easier to think of it that way. Okay, so I have a negative sine wave, okay, with a period of 20, shift to the left 25, which means my first point, since I'm not graphing until 5, is right here. Okay, and then at 10, I should be at the max, and then midline, and then max, and then midline. Okay, that is my wave that I'm going to be graphing from. And my final answer is the cosecant wave. So again, wherever sine has a 0, cosecant has a vertical asymptote. And we just sketch. So wherever this one has a max, this one has a min. Wherever this one has a min, this one has cosecant has a max. And there we go. All right, number 9. We've got a cotangent wave. Okay. We've got a reflection over the x-axis, so negative cotangent. We've got a vertical stretch by a factor of 2. We've got a period, well, a cotangent normally has a period of pi, so pi over, well, okay, that's a little bit weird, but just the 2, if you will, because what I'm going to do is I'm going to factor out the negative 2 theta, and then what you're left with is minus pi over 4. So if you want to be able to see your transformations, you can also just factor. But b is technically just the 2 out front, okay? So pi over 2, which means the period is just pi over 2. Okay. Your phase shift, you're going to go negative c over b. So that's negative pi over 2 over b, which is just the 2, divided by 2 over 1, so this multiplied by 1/2. So that's negative pi over 2 times 1/2, which is negative pi over 4, which you see right there. We're going, let's see, let me make sure. We're going to see, going left, which is you're going right. I wonder if that formula includes. I guess in this formula it has to be the negative. I don't like that. Okay, but I think we should, well, okay, if you factor out the negative, that makes it negative. We know we should be going to the right. That's still weird. I guess in the formula they're saying negative c over b, and whatever that number is, they're including the negative with it. You wouldn't include it here because period doesn't make sense to be negative. But okay, I'll take it. Okay, pi over 4. So we're going to go to the right pi over 4, which you can definitely see right there. The right pi over 4. And then minus 3 means go down 3. So we're going to go down 3. 1, 2, 3. We're going to, forgot what I was doing for a second. Okay, cotangent. So cotangent, normally cotangent is such that you have a vertical asymptote starting at 0, and then what you do is you go 2 tick marks and you let the second tick mark be the period. See where tangent spans on either side of the x-axis right here. Cotangent, you let it be 0 in the period. And then cotangent, unlike tangent, so tangent starts from below and goes up. Cotangent starts from above and goes down. So normally cotangent looks like this. Yeah? So that is just a cotangent wave. But we've got a negative cotangent wave, so in general, we're going to be looking at something along the lines of this. So if it starts from above and goes down normally, then it starts from below and goes up, so it looks like a tangent wave. Shift it over, right? Okay, now, like I said, we normally let the second tick mark be the period. In this case, the period is pi over 2. So if that's pi over 2, then that makes this pi over 4, right? Well, we're supposed to go to the right pi over 4. So if pi over 4 is 1 tick mark, then we're going to go to the right 1 tick mark. Okay, fair enough. So let's make sure I can fit all that in there. I need to go from negative pi over 8 to 3 pi over 4. Interesting. Okay, so if I let 2 tick marks be pi over 2, and that's the period, and that is pi over 4. That's 1/4, this is 2/4, this is 3/4. And then if this is pi over 4, then half of that is pi over 8. I guess I was thinking to do 2 tick marks, but whatever. Okay, so here's what I know. I know that normally my negative cotangent would look like this. I need to go to the right pi over 4, which is just 1 tick mark. So what was a vertical asymptote here is now a vertical asymptote at pi over 4. And this vertical asymptote, oh sorry, let's go with this one. This point, which was at pi over 4, is now at pi over 2. And this vertical asymptote, which was at pi over 2, is now at 3 pi over 4. So every other tick mark is a vertical asymptote. And then I also know that if this is a 0, then so is this one, right? So my wave is going to look like, oh, just kidding, I've got one more point to do. The vertical stretch. So we need to go to the left half a tick mark and go down 2. And to the right, a half a tick mark and go up 2. Half a tick mark and go up 2. Half a tick mark and go down 2. So that is actually the last point we'll graph, or the last part we'll graph. So my wave actually looks like this. It stops here, and then there we go. So we have 1 3/4 of a cotangent wave, a negative cotangent wave. All right, interesting. All right, number 10. Find the exact value of each expression. Okay. Sorry, I realized I was going to need a unit circle for this. Okay. So, actually, I mean, I guess I don't, but yeah, I'll go ahead. Secant inverse of the square root of 2. Yeah? So secant, I guess we didn't even really talk about those, did we? Okay. I didn't talk to you about secant inverse. I talked to you about cosine inverse, sine inverse, and tangent inverse. So I'm going to work this one the way that we would work some of these down here. So I don't want to confuse you. I know that secant inverse is the reciprocal of cosine. So if I'll let that be theta, then what I'm trying to do is you take the secant of both sides, and the square root of 2 over 1 is cosine of theta, right? So we'll go in the first quadrant, and I'm pretty sure secant and cosecant inverse follow the rules. Sorry, I'm talking to myself at this point. Just give me a second. I just don't want to tell you anything wrong. Or we can work it out this way, but I just want to make sure I'm not doing something wrong. Okay. So okay. You know what? We're just not going to worry about it because I don't want to do something that I haven't asked you to do. Because I didn't talk to you about where secant inverse and cosecant inverse and cotangent inverse exist. So we're just kidding on all of these. That's kind of annoying. Okay, we got the ones in the book. So I'm just not going to worry about those. I mean, okay. Obviously, if you want to know when secant inverse is the square root of 2, or secant inverse of the square root of 2 is when cosine is the square root of 2. Sorry. I don't even know why I wrote that. It's when secant. So it's when cosine equals 1 over the square root of 2, which is square root of 2 over 2. That's in 2 different places, but what I haven't talked to you about is where secant inverse and cosecant inverse exists. So yeah, don't worry about those. Okay, just kidding. Dang, I did that on something. Okay, so we're not going to worry about that one. That one. We can do that one. That one's fine. This one, no, no. Nope, not going to do it. Okay, let's just do these. Cotangent of sine inverse of 4/5. Yeah? So what I know is that sine inverse of 4/5 is an angle, and it's an angle for which sine of that angle equals 4 over 5. Sine is positive. You got sine inverse only exists in the first and fourth quadrants. So sine inverse of theta is 4 over 5. So sine is opposite over hypotenuse. If that's 4 and 5, then this has to be 3. So then the question is, what is cotangent of theta? Cotangent is adjacent over opposite, so that is 3 over 4. On 16, okay, so this is cosine inverse of cosine of pi. So cosine of pi is just -1. So then the question is, cosine inverse of -1 equals what angle, right? So then you take the cosine of both sides, so -1 is cosine of what angle? And that angle is pi. So could I have just canceled these out? Yes, because they both exist at pi. Because cosine inverse exists from 0 to pi. All right. Number 18 has cosine inverse, so we're not going to do it. And number 19. Okay, so tangent inverse only exists in the first and fourth quadrant, and is positive only in the first. So I've got tangent is opposite over adjacent, which is x over 1. So if this is theta, then that means tan inverse of x over 1 equals theta. X over 1 is tangent of theta. So tangent is opposite over adjacent, yeah? And then Pythagorean theorem says a squared plus b squared equals c squared, or c equals the square root of a squared plus b squared. So the square root of x squared plus 1. So I need tangent of this. Well, it's just kind of silly. Tan and tan inverse will cancel each other out, and they just leave you x over 1. But if you work it all out, like I did, you get tangent of theta is x over 1. That's a long way to get to that answer. Okay. Cosine of tan inverse. Cosine of tan inverse. Okay. So all of this is some angle for which, so if tan inverse of this 16 minus x squared equals theta, then that means x over the square root of 16 minus x squared equals tangent of that angle, right? Again, tangent is positive only in the first quadrant. So tangent is opposite over adjacent. Tangent of theta is this. Square root of 16 minus x squared. And then the formula for the hypotenuse is a squared plus b squared. Take the square root of that. So you're left with the square root of x squared plus 16 minus x squared, which is the square root of 16, which is 4. So then the question is, what is cosine? So cosine of theta is adjacent over hypotenuse. And that would be my answer. In this one, we've got cosine of sine inverse of 2x over 1. So, sine inverse of 2x over 1 equals theta, which means 2x over 1 equals sine of some angle, right? Sine inverse first and fourth positive here. So, opposite over hypotenuse, which makes this right here. If you want to find a or b, then it's the square root of c squared minus a or b squared, which is the square root of 1 minus 4x squared, because you have square 2 and x. Okay? So then cosine will again be adjacent over hypotenuse. Cosine of theta equals the square root of 1 minus 4x squared over 1, or just the square root of 1 minus 4x squared. Okay.